Deja vu, I've just been in this place before. Higher on the street, and I know it's my time to go. Going new, and the search is a mystery. Standing on my feet, it's so hard when I try to be me. Whoa, deja vu, I've just been in this time before. Higher on the beat, and I know it's a place to go.
Okay, hello everyone. And I want to thank the organizers of this wonderful conference for having us again. We have an interesting story to tell. We're going to be following up on the great presentation by Roman and Alexei, telling you more details about the malware that's behind this last Ukrainian blackout. It's the first ever, it's historically the first malware specifically designed to attack power grids automatically. And throughout the presentation, you'll probably understand why we consider it to be the biggest threat to ICS since Stuxnet. I'm Robert, this is Anton. We work for ESET, the Slovak cybersecurity company, who's been on the market for the past 30 years, and we're based in Bratislava, Slovakia. Okay, so we have a lot to cover, so this is the agenda, but I'll jump right into the context. So Industroyer, it joined this exclusive club of only 3 previously known malware families that were known, identified to be used in attacks against ICS. This one needs no introduction, right? Stuxnet was used to reprogram PLCs. Havix, the malware behind operations called Dragonfly or Energetic Bear, was used to target many industrial sites, mostly around 2014, but there were also some campaigns this year. Symantec has a really interesting report on that. I recommend you give it a read in case you haven't. What's interesting about Havix compared to, and relating it to Industroyer, is that it also abuses the OPC-DA protocol, which we'll be talking about later on. But unlike Industroyer, Havix only uses it for espionage. It doesn't directly control the ICS processes. Now, BlackEnergy is a little bit different from these other 3 malware families. I don't want to talk too much about it because we covered it last year, but I'll just point out the big difference between BlackEnergy and these others. It wasn't built specifically to target industrial control systems. Instead, it's a more general-purpose cyber weapon. And we were tracking it for many years now. Over those years, there were many campaigns, some of which you can see the decoy documents from these spear phishing campaigns, which you see on the screen. There were many high-value targets, mostly in Ukraine, but also in other parts of the world. So there were mostly espionage campaigns. But there was also the one we all know, what happened on December 23rd, 2015, where the attack culminated in the first ever known malware-induced blackout in history. But, so, as I said, it's a more general-purpose cyber weapon. So BlackEnergy is a modular piece of malware, a malicious framework, if you will, and supports plugins. So these are a couple of the plugins that we saw that BlackEnergy was using, and as you can see, they're mostly plugins providing the spying functionality. And also network traversal functionality and so on. So the actual blackout, it was caused when the attackers remotely connected to that critical, to that workstation operating the industrial process, the circuit breakers. This is an actual log from that evening showing that the attackers connecting. And this is a video taken by one of the operators while the intrusion was happening. I'm sure many of you saw this video already. For those of you that haven't, it's also publicly available now on the internet. You can find it. Okay, but on to the main topic now. So here's a timeline of the events that happened regarding the last blackout. So on December 17th, 2016, which is almost exactly 1 year after the BlackEnergy induced blackout, we were struck with a sense of déjà vu. So there was another one, another black cow. We started analyzing samples of malware, which became the main suspect shortly afterwards. Had our preliminary report ready and shared it with the Ukrainians on the 18th of January. And then actually we had to be silent, as this is quite a sensitive issue, and only got the green light to reveal, to go public with these findings in June. We shared our report ahead of time, ahead of publication, with our colleagues at Dragos under TLP Amber, and then the report went public on Monday, the 12th of June. So this is a scheme of how Industroyer works, and we'll take a look under the hood, explaining the little bits and pieces. So basically, it contains a timer, and we'll tell you more details about that, that activates the functionality at a specific time, which will then lead to the circuit breakers being opened. So we'll walk you through the overall infrastructure, the overall architecture of the malware, the malicious framework. It starts with the main backdoor, which is the entry point of the whole functionality. The main backdoor isn't really that interesting. It's one of those pieces of malware that we in the lab analyze every single day. Here's the list of commands that the backdoor accepts, that the backdoor is able to fulfill. I'll just highlight a couple of the noteworthy ones. So as you can notice, compared to the BlackEnergy modules, for example, it's not really built for espionage functionality. There is, however, code which is able to exfiltrate files, which was used, and as Roman and Oleksiy already mentioned, the execute shell command, it will produce an output to basically log files in the temporary directory, which can then be uploaded to the attacker and to see what was going on there, and B, it was also a source of information for us to reconstruct the execution chain and to find out what was happening at the time of the attack. So we were able to find out that these steps, the attack was happening in multiple stages. As you can see here, there was some VBS scripts, some C scripts involved. But the interesting part is the use of the compromised MS SQL database that the ISSP guys already also mentioned. So this is actually really interesting, and it's a really cunning technique that the intruders use to stay under the radar. So basically, how did they infiltrate this database? So they got hold of an in-house custom application that stores environment layouts, ICS environment layouts and telemetry, stuff like that. You can see some screenshots of this application up on the screen. They reverse engineered that application and found, in order to discover that the application stored hard-coded credentials to the MS SQL database where it stored all that information. So, okay, this was a really good opportunity for the attackers, so they took advantage of that. They activated the XP CMD shell functionality of the database, and then they were able to execute arbitrary shell commands from within the context of the database, making them less suspicious. And also, they were able to store malicious binaries within the database, which is a pretty clever technique. Okay, some other interesting functionality of the backdoor, the way it installs itself, for example, the way it ensures persistence. It's using this last command, so it will replace the image path Windows registry value and set it to itself, a more obfuscated version, a copy of itself. And then there's an additional backdoor, also already mentioned, masquerading as the Windows Notepad application, which the attackers Trojanized. And what's really interesting that a very similar technique was also used in the Dragonfly campaigns this year. There are also a couple of other modules that are launched by the main backdoor. One of them is a denial of service tool. It directly affects the ICS. We'll get to that in just a second. And then there's the custom-made port scanner. So the attackers could have used some readily available tools, such as Nmap, for example, but instead they created their own. These are some of the ports that they were scanning the network for. Okay, and now we're getting to the really interesting part. So the main backdoor launches a launcher component, and which is responsible for activating the payloads at a specific time. Now, before we talk about the individual payload components, we identified 3 distinct ways in which Industroyer attacks and interferes with the operation at the electricity substation. So firstly, and most importantly, it can directly control the industrial hardware in order to open circuit breakers. So speaking of this hardware, I think you guys in the audience probably know a lot more about these devices than I do. So we're talking about protection relays. Here are a couple of examples from affected vendors, Siemens and ABB. Now, these devices, they're controlled and monitored, as we all know, by regular workstations, typically running Windows, and administrated by applications such as these examples. So here we see an example of ID Scout, Intelligent Electronic Devices, as the devices are called, or here's another one, PCM 600. And the communication between the controlling Windows workstation and these devices, it happens over one of several industrial control protocols. Now, there are many different protocols. Some are regionally specific. Some operate over a serial connection, some over TCP/IP. But the overall idea is the same, to send commands, and then through that, the attackers were able to accomplish their goals. So with that, I pass on the microphone to Anton, who will walk you through the analysis of the payloads.
Okay, thank you, Robert. Robert already mentioned that the exact timing of Industroyer attack, and that's the job of launcher component. We analyzed the launcher component, and the samples that we analyzed, they contain hard-coded date, and this date is December 17, shortly before the power outage. We identified modules capable of controlling devices through 4 different communication protocols, IEC-101, IEC-104, 61850, and OPCDA. Most of them, they're DLL files with their own configuration. Let's take a look at first payload. First payload, it's 101. It requires a configuration file, and here is okay. Here is an example of configuration, but this configuration, it was not the real configuration that was used. It's just a reconstructed example. So it communicates over serial connection. The COM ports they use, they defined in the configuration. And first thing it does, it kills legitimate process on the workstation that responsible for control devices and takes over. And attackers can define the process name here. The devices, they operate on something that's called IOA, Information Object Address. Think about them as network ports or registers. There are several different types of IOAs, but attackers they are interested only in 2 specific ones that can accept commands. It goes over a range of these IOAs defined in the configuration, and it sends the command sequence off, then on, then off again. And here you can see we defined 2 ranges. First range from 10 to 15, second range from 20 to 25, but we can define as many ranges as we want. So next payload is 104. It is very similar to 101. It sends on or off commands, but it operates over TCP/IP. There's some difference that It has more configuration options. As you can see here, it's possible to specify multiple station entries, and it allocate new thread for each such station, so it will connect to this station in parallel. There are 3 modes of operation. Here we can see range, but there is 3 modes: range, shift, and sequence. And both for 101 and 104, attackers, they don't know the type of IOAs, so they have to do some kind of brute force, which will to find out which IOA will accept the command. So range and shift, they are used to discover right IOAs, and sequence is used when IOA is unknown. Payload construct packet on the fly. Thankfully, to Wireshark, we can dissect them. And as you can see on this example, is a single command type IOA, or single command type on IOA number 10. So it sends on command, and there is 2 sequences. At first, it should send select command, select, and then it should send execute command. The payload can also write. It has option to write to console, so attackers, they can see real time what's going on. And in addition to that, it has support. It has option to log to the file. And this is an example. It demonstrates capability of the payload. It tries to switch circuit breakers to on or off in an infinite loop. The exact logic depends on configuration, either on or off continuously, or flipping back and forth between iterations. And this, as you can see here, we have on, and then it goes through range of IOS, and then it flips the value. The next payload is a bit different and a bit more advanced. Like 104, it operates over TCP/IP, but it can function even if configuration is not defined. So it has a feature that allows this payload to auto-discover these devices in the network. So it can scan ports. It does not operate on IOAs, but on named elements. It looks for these hard-coded names. They correspond to circuit breakers. It's a bit different approach, but purpose is same, to open circuit breakers. So the last payload is a step above the rest. Not that it's more advanced, but it operates on higher software abstraction level. Technically, OPC data access can be built on top of 101, 104, 61, 850, or Modbus. It uses distributed COM to discover all OPC servers running in the network. It obtains their named items, and it searches for these specific tags. Then it addresses byte value 1 to items with these tags. But what does it mean? Let's take a look to the documentation. And these tags, they are associated with ABB. Their type is ABB command bit mask. And as you can see here, writing value 1 on bit position 0 result in normal execution of that command. Why I'm describing this in such details? Because there is a report that's saying because it writes 1, it's some kind of denial of visibility attack. But as you can see, it's not the case here. We can map, using this tool, we can map or translate the command into a better human readable form. And as you can see here, this tag, it means breaker open execute command. So again, the purpose is the same, to opening circuit breakers. And analyzing Industroyer payloads, it's an easy task but for skilled reverse engineer because the payloads and models, they not obfuscated in any way. But the only thing that can slow down your research is this annoying COM-star. And to help to analyze any future malware that will use OPCDA protocol, we released this IDA Python script. And that's how disassembled code looks before you apply the script. And that's how it looks after. Albert?
Well, I guess all the reverse engineers in the room will agree that that's much better, much nicer to analyze. So all these payloads, they serve a similar purpose, to open and close circuit breakers. Now, the outcome of that is probably pretty apparent, de-energizing a substation. I guess you might ask, so why would you want to cyclically open and close circuit breakers in an infinite loop? Maybe it has to do with them wanting to cause some more permanent damage. You've seen in 2007 with the Aurora generator test what out-of-sync opening of circuit breakers could cause, but I guess that's up for discussion whether that was really their intent. Okay, so the second type of functionality we found in the framework is rendering protection relays irresponsive. This is done by the denial of service tool, which I mentioned earlier on, and it does so by exploiting a vulnerability in Siemens CProtect devices, as described in this ICS CERT advisory. So it does, and specifically, it does so by sending specifically crafted packets to UDP port 50,000, as you can see in this excerpt from the code. So knocking these devices out mostly serves to amplify the effect of the payloads that Anton was talking about. Now, Siemens did patch the vulnerability in a firmware update, but you guys all know how often, how regularly these devices actually get updated. So the third and final type of functionality we identified in Industroyer is the data wiper module. Its purpose is to make recovery from the attack more difficult. It's executed by the launcher component either 1 or 2 hours after the ICS payload modules ran, so 1 or 2 hours depending on the sample. And remember those screenshots of the SCADA application that I showed you? Well, those are the types of applications, the configurations for those types of applications which the attackers were after. Some of the examples of the affected software is listed here. So what will this module do? It will wipe the files belonging, search the drives, wipe the files, rewrite them, to files belonging to this SCADA software. Then it will make the machine unbootable by corrupting the registry, and eventually crashes it by killing all including system processes. So if you're a substation operator, you see that your circuit breakers are continuously being reopened, your protection relays are irresponsive, and when you want to sit down and fix the problem, you find that your SCADA software is gone. So it's a pretty nightmare scenario, and fortunately, it was really cool that the attack, the blackout, only lasted 1 hour, and they were able to restore the power so quickly. Okay, so as we've shown you, some of the functionality is vendor agnostic. For example, 101, 104, while others is tailored specifically for some specific device vendors, such as the Siemens CProtect vulnerability or the OPCDA. It's specifically targeting ABB devices. Now, among the files where the other malicious files were stored, we also discovered this, which is boot code for General Electric devices. Now, we don't know if and how this was used by the attackers, but it hints that they were ready to attack also hardware by different vendors. So with that, I'm going to wrap up with a couple of takeaways. Firstly, this happened to Ukraine repeatedly, but it could happen anywhere in the world. Now, these protocols, they're used all over the world, and it's just a matter of dedication, motivation of the attacker to carry this attack somewhere else. And that has to do with these additional 2 points. So, yes, this malware is pretty. I know we're not supposed to say superlatives, good things about malware, but it's pretty impressive. But that's not the most dangerous part about the whole thing. It's about the skill set and dedication of the malware operators. So one thing is coding the malware, but the other thing is doing the research, understanding, because this is not what malware writers are typically doing. This is not the typical skill set of malware writers. So they have to become familiar with the architecture that they want to target. They have to find out what devices there are. They have to do a lot of reconnaissance. They have to understand what commands to send to those devices and what will happen as a result. Now, and the other thing is the unfulfilled potential. If you think about it, compared to the 2015 attack, for example, the attack grew a lot in sophistication, but it was only one region for 1 hour. So it's probably not the worst that they could do. So either it was a test, it was a demonstration of these, or they failed somehow. They probably wanted to achieve more. Well, these are certainly some things to think about and to discuss. This is some interesting artifact that we also noticed. They renamed the log file from the 104 module to IC104 sev.log. Now, sev would most probably mean north in Russian, sever, and the Kiev North substation was affected. Now, why were they renaming the log file if they were only targeting one substation? So perhaps they were, again, purely speculation, but perhaps they were also interested in other targets as well. Also, we don't know a lot about the attackers. They didn't leave many clues behind. This is like the only one which we can draw some conclusions. Again, this is no definite evidence whatsoever, just a clue, which could be a false flag, of course. But sever is north in Russian, not Ukrainian, so perhaps they are Russian-speaking, maybe. So yeah, we don't know a lot about them, and it's going to be an interesting discussion as to who these guys may be. Now, there are colleagues, ISSP, Dragos, for example, who say that they are the same people as behind the 2015 attack. So it's going to be really interesting to hear some supporting facts for those statements. And with that, I open up for the discussion. Thank you.
Thank you very much. Yes, you really put the scene for an interesting discussion. But I still think we could just shoot one question that is dedicated for you specifically. Hope I will find something. Yeah, have you found any evidence that links Industroyer to the Sandstorm team?
We have not, no.
No, so that was obvious. And this is things that will be discussed during the panel that will follow. So maybe we should just save the questions for the panel, and Robert has picked them up. But before that, I would like to thank you very much for your contribution to this summit. It's valuable.
Thank you.
Thanks a lot, and a warm applause.
Thank you.
Thank you.